Welcome to Compact Disasters from compacthistories.com, where we look at catastrophes, accidents, and natural disasters in short, bite-sized episodes. This is episode 90, the Ronan Point collapse. In the years after the Second World War, Britain faced an immense housing problem. Bombing had destroyed or damaged homes across the country, while much of the surviving housing stock was overcrowded, poorly maintained, or lacked basic facilities. Successive governments promised to clear the slums and construct hundreds of thousands of modern homes. In densely populated parts of London, where land was expensive and demand was relentless, building upwards appeared to offer an efficient solution. The tower block became a symbol of that ambition. Residents could be moved from aging terraces into flats with bathrooms, central heating, and uninterrupted views. Yet conventional construction was relatively slow, and councils were under pressure to deliver homes quickly. This encouraged the adoption of industrialized building methods in which large components were manufactured in factories and assembled on site. Ronan Point was built on the Freemasons' estate in Canning Town, in the newly created London borough of Newham. Named after Harry Ronan, a former chairman of the local housing committee, it was the second of 9 similar towers planned for the estate. Construction began in 1966, and the block was completed on the 11th of March 1968. It stood 22 stories high, reached approximately 64 metres, and contained 110 flats. The main contractor, Taylor Woodrow Anglian, used a version of the Danish Larsen and Nielsen large panel system. Instead of relying upon a strong concrete or steel frame, the building was assembled from prefabricated concrete wall and floor panels. These were lifted into position by crane, stacked together and connected at their joints. The walls supported the floors above them, making the correct positioning and secure connection of every component essential. Large panel construction offered considerable advantages on paper. Factory production promised consistent components, while rapid assembly reduced the need for highly skilled labor on site. Once the foundations were prepared, a tower could rise with remarkable speed. The method suited a housing program concerned with quantity, standardization, and cost. Its weakness was that the structure possessed little tolerance for error. The system depended upon each load-bearing panel remaining in place and transferring weight through the building. If one vital panel failed, the loads above it needed another safe route to the ground. Ronan Point had not been designed with adequate alternative load paths, while its joints provided little resistance to forces pulling its components apart. These shortcomings were not apparent to the families moving into their new homes. By May 1968, the building had been occupied for only about 2 months. Early on the morning of the 16th, most residents were asleep. In a corner flat on the 18th floor, however, a leaking domestic gas connection had quietly prepared the conditions for disaster. Flat 90 was occupied by Ivy Hodge, a woman in her 50s who had moved into Ronan Point only weeks earlier. At approximately 5:45 on the morning of Thursday, the 16th of May 1968, she entered her kitchen and prepared to make a cup of tea. When she struck a match to light the cooker, accumulated gas ignited. The explosion that followed was not exceptionally powerful, but its location and the building's structural arrangement made its consequences devastating. Investigators later traced the leak to a fractured brass nut connecting the gas supply to the cooker. The nut had probably been over-tightened during installation, creating a crack through which gas escaped. Some of it accumulated around the kitchen and adjoining hallway. The precise pressures produced by the ignition became an important subject during the investigation. But the essential fact was unmistakable. An ordinary domestic gas explosion had struck load-bearing parts of a high-rise building. The blast knocked Hodge unconscious and caused burns and shock, yet she survived. Remarkably, much of the kitchen remained in place, and the cooker itself was not destroyed. Elsewhere in the flat, however, the explosion pushed out concrete panels forming part of the external flank wall. These panels were not simply cladding intended to keep out the weather, they helped carry the weight of the flats above. Witnesses outside heard an explosion and then a noise variously described as a roar or a prolonged rumble. The southeast corner of the tower appeared to peel away. Furniture, concrete slabs and household possessions fell through the air as rooms that had existed moments earlier were opened to the sky. Dust spread across the estate while surviving sections of the building remained standing with their interiors exposed. The timing and pattern of destruction prevented an even greater loss of life. Most occupants were still in their bedrooms, while the collapse primarily tore through living room areas. Several flats above the explosion were also unoccupied. Had the blast occurred later, when families were moving around their homes, the number of casualties might have been far higher. 4 residents were killed directly: Thomas and Pauline Murrell, Thomas McCluskey, and Edith Bridgestock. 17 people were injured. Some later accounts give a death toll of 5, because another resident, Ann Carter, died in hospital about 2 weeks afterwards. Her death was not officially attributed directly to injuries from the collapse, which is why the accepted official toll is usually 4. Dock workers from nearby Royal Victoria Dock joined police, firefighters, ambulance crews, and local residents in the first rescue efforts. Yet even as survivors were being brought to safety, one urgent question was already taking shape. How could such a limited explosion remove an entire corner of a 22-story tower? The answer lay in the chain reaction that began when a single structural wall was displaced. When the explosion forced out the 18th-floor flank wall, it removed support from the building directly above it. The floor and wall panels of the 19th story could no longer transfer their weight through the intended vertical path. They fell onto the 18th floor, carrying components from the floors above with them. That accumulated mass then struck the 17th floor, which had not been designed to absorb such an impact. The process continued downwards. Each newly overloaded floor failed and added its concrete panels, furniture and debris to the descending weight. Within seconds, the living room sections at the southeast corner had collapsed from the top of the tower to the ground. Engineers call this a progressive collapse. Local damage spreads from one component to another until the resulting destruction is grossly disproportionate to the event that initiated it. A robust building does not necessarily remain undamaged after an explosion. It is instead designed so that the loss of one structural element does not bring down a substantial portion of the whole structure. Loads may be redistributed through surrounding columns, beams, walls, or ties. Ronan Point lacked sufficient continuity and alternative load paths to arrest the sequence once it had begun. Its large panel system behaved rather like a structure assembled from stacked boxes. Each story depended heavily upon the panels beneath it, while gravity helped hold the components together. The joints were expected to connect adjacent floor and wall panels, but they were poorly suited to resisting an outward force. When the explosion lifted part of the floor slab and pushed the wall away, the stabilizing weight at the joint was reduced at precisely the moment it was most needed. The tower's vulnerability was not limited to gas explosions. If a severe fire, exceptionally strong wind, or another accident displaced a critical panel, the same lack of structural continuity might allow failure to spread. This transformed Ronan Point from an isolated domestic accident into evidence of a much broader problem. Other blocks had been constructed with comparable systems, and thousands of families were living inside them. Initial statements from the contractor resisted the suggestion that the building itself had failed. The explosion, however, had been relatively small. A properly robust 22-story structure should not have lost an entire corner because of an event that might ordinarily have damaged a single flat. The scale of the collapse demonstrated that the tower's design had converted a local accident into a major disaster. The mechanics of the failure also complicated the rescue. Huge slabs had fallen almost vertically, crushing rooms and forming unstable layers of rubble. Meanwhile, hundreds of residents had to be removed from the surviving portion of a building whose safety could not yet be guaranteed. Emergency workers were therefore operating amid physical danger, uncertainty, and the growing fear that Ronan Point might not be the only tower at risk. The first people reaching Ronan Point encountered a scene that was both catastrophic and strangely uneven. Most of the tower remained upright, but one corner had disappeared from roof to ground. Rooms stood open like compartments in a cutaway model. Curtains, wallpaper and furniture remained visible beside shattered concrete, while other household contents lay scattered across the estate. Emergency services established a perimeter and began searching the debris. Firefighters climbed through damaged flats and checked whether occupants were trapped in the standing portion. Police organized the evacuation and tried to account for residents, a difficult task in a recently opened block where some flats were still empty. Ambulance crews treated casualties as rescuers, including dock workers and local volunteers, helped people away from the building. One of the most precarious rescues involved a woman left stranded high above the ground after much of her room vanished. Photographs of survivors standing near exposed edges conveyed the instability of the scene. Firefighters had to reach people without placing additional stress upon damaged panels whose behavior was uncertain. Heavy equipment could not simply be driven into the rubble until engineers had considered the risk of further collapse. The 4 people killed occupied flats within the vertical path of falling concrete. Thomas and Pauline Murrell lived on the top floor. They had reportedly rejected several offers of accommodation before accepting their flat because their previous home had been condemned. Thomas McCluskey and Edith Bridgestock lived below the flat where the explosion occurred. Their deaths illustrated how the structural failure travelled in both directions from its starting point, first upwards through loss of support, then downwards through impact. Ivy Hodge was taken to hospital suffering from burns and shock, but escaped the destruction around her. Her survival became one of the disaster's most remarkable details. The woman whose match ignited the gas had been closest to the explosion, yet the kitchen protected her while the resulting structural collapse killed residents several floors away. By the end of the operation, 17 injured people had been recorded. The relatively low casualty figure brought relief, but it did not lessen the shock. Approximately 260 people had been living in the block, and the circumstances had spared many of them largely by chance. A different time of day, fuller occupation of the upper flats, or a collapse through the bedroom side could have produced a vastly greater toll. The surviving residents were displaced, and many were unwilling to return even when officials later declared portions of the building safe. Their fear extended to neighbouring towers, constructed by similar methods. The government could not treat the event as a freak explosion and proceed as before. On the 20th of May, Housing Minister Anthony Greenwood appointed a public inquiry under the chairmanship of Hugh Griffiths, QC. Its task was to establish exactly what had failed and determine whether Britain's programme of industrialised high-rise housing had placed other communities in danger. The inquiry examined the gas installation, the behaviour of the concrete panels, and the standards governing the tower's design. Its report, published later in 1968, confirmed that leaking gas had caused the explosion and that the blast had displaced load-bearing flank wall panels. Their removal initiated the collapse of the southeast corner, both above and below flat 90. This conclusion exposed an alarming regulatory gap. Ronan Point had been constructed in accordance with the building rules then applicable, yet those rules had not required the structure to remain stable after the accidental removal of a load-bearing wall. Designers had considered the normal downward weight of the building, but insufficient allowance had been made for an abnormal outward pressure or for the redistribution of loads after local damage. Tests indicated that the critical wall panels could be displaced by pressures well within the range of a domestic gas explosion. The connections between panels lacked the strength and continuity needed to hold the structure together. Rather than operating as an integrated three-dimensional frame, the tower depended upon stacked components whose stability could be lost when their joints opened. The inquiry also considered the implications of wind and fire. High winds could impose repeated lateral forces upon the building, while fire might cause thermal expansion, distortion, or weakening of structural elements. Ronan Point's inability to tolerate local movement meant that the concern could not be resolved merely by repairing the failed gas connection or banning one particular model of cooker. The report recommended that tall blocks using large panel construction be professionally assessed and strengthened where necessary. Gas supplies in vulnerable buildings were to be removed unless the structures could withstand specified explosive pressures. Ventilation and gas installation procedures also required attention, while new buildings needed protection against progressive collapse. Although the original inquiry concentrated primarily upon design, concerns about workmanship persisted. Ronan Point was repaired, strengthened, and eventually reoccupied, but residents and independent experts continued questioning its condition. Architect Sam Webb, who had contributed evidence to the inquiry, became a prominent critic of the official assurances. Those concerns gained powerful support when Ronan Point was dismantled in 1986. Because it was taken apart floor by floor rather than destroyed by explosives, investigators could examine joints that had remained hidden. They found serious defects, including inadequately secured connections and spaces that should have contained concrete packed instead with debris and newspaper. The discoveries suggested that hurried or careless construction had further reduced the safety margins of an already vulnerable design. The inquiry had established why the corner collapsed in 1968. The later dismantling demonstrated that the problems went beyond the panels directly affected by the explosion. Ronan Point represented a failure of design assumptions, construction quality, and regulatory oversight. Britain's next task was to translate those lessons into rules capable of preventing a similarly minor accident from producing another catastrophic chain reaction. The government introduced interim measures soon after the inquiry. Tall buildings constructed from large concrete panels had to be examined for their resistance to accidental forces. Where adequate resistance could not be demonstrated, gas supplies were removed and cooking and heating converted to electricity, or the structures were strengthened with improved connections and bracing. For new blocks of more than 5 stories, official guidance required resistance to an internal pressure of 5 pounds per square inch, approximately 34 kilopascals. Existing blocks could be accepted at a lower resistance of 2.5 pounds per square inch, approximately 17 kilopascals, if piped gas was removed. These figures gave engineers a defined accidental load against which vulnerable structures could be assessed. More fundamental change followed through amendments to the building regulations. The concept at their heart became known as disproportionate collapse. A building should possess sufficient robustness that damage caused by an accident remains proportionate to its original cause. Designers could meet this principle through strong horizontal and vertical ties, alternative load paths, protected key structural elements or arrangements that limited the extent of collapse following the loss of one component. The implications reached far beyond gas safety. Explosions, vehicle impacts, fires, construction errors, and other unforeseen events could all remove or weaken an individual structural element. Ronan Point demonstrated that engineers had to consider not only whether a building could carry ordinary loads, but also how it would behave after something went wrong. The disaster also damaged confidence in the wider high-rise housing program. Tower blocks were already attracting criticism over unreliable lifts, difficult maintenance, social isolation, and unsuitable living conditions for families. Ronan Point added the fear that industrialized construction had placed speed and economy ahead of structural resilience. Although British councils did not immediately stop building high-rise homes, enthusiasm for large panel towers declined sharply. Ronan Point itself was rebuilt and reinforced, but never escaped the shadow of the collapse. Continued campaigning by residents and experts led Newham Council to evacuate it during the 1980s. The block was dismantled in 1986, and its 8 sister towers on the Freemasons' estate were subsequently demolished. Low-rise housing eventually replaced them. The legacy of Ronan Point is not that all prefabricated buildings or tower blocks are inherently unsafe. It is that structural systems must tolerate local failure, construction quality must match the designer's assumptions, and regulations must account for accidents that may seem unlikely. 4 people died because a fractured gas fitting initiated a sequence that the building had no effective means of stopping. A cup of tea, a match, and a small domestic explosion exposed weaknesses hidden inside one of Britain's newest homes. The southeast corner fell in seconds, but the lesson endured. When buildings reach upwards, safety cannot depend upon every component behaving perfectly forever. That brings us to the end of this episode of Compact Disasters, part of the Compact Histories Network. If you enjoyed it, please follow or subscribe wherever you're listening so you don't miss any future episodes. And consider leaving a rating or review, as it really helps new listeners find the show. You can find more episodes at compactdisasters.com, where you can also explore our other podcasts covering biographies, history, true crime, warfare, and mysteries. You can also follow us on Facebook, Instagram, and Pinterest. Finally, please consider supporting the show directly by buying us a coffee. Head on over to compacthistories.com/disasterscoffee to see how. Thanks for listening, and I'll see you next time.